In this video, we're going to be looking at applications of the square root property. And in 1, it says this problem examines the relationship between the sides of a 45 degree, 90 degree triangle. In A, it says refer to the triangle to the right and find the length of the hypotenuse in terms of A. So we're going to use the Pythagorean theorem, and we're going to have A squared plus A squared is equal to C squared. And now we want to solve for C. So we're going to have 2a squared, and that's equal to c squared. And now to solve for c, we're going to take the square root of both sides, and we're going to get c is equal to the square root of 2a squared. And the square root of a squared is a. So we can rewrite this as c is equal to a times the square root of 2. And B, it says find the length of the sides if the hypotenuse has a length of 1 unit. So that would mean that C is equal to 1. And we need to find A. So we have A squared plus A squared is equal to 1 squared. And then 2A squared is equal to 1. And if we divide by 2, we get A squared is equal to 1/2. And now we can take the square root. So we have A is equal to the square root of 1 over 2, which can be written as 1 over the square root of 2. And then we would want to rationalize the denominator. So it would be equal to the square root of 2 divided by 2. In 2, it says this problem examines the relationship between the sides of a 30, 60, 90 triangle. Refer to the triangle to the right, find the height of the triangle. Your answer will be in terms of A. So we want to find the height, so we're trying to solve for H. So we're going to have A squared plus H squared is equal to 2A squared. And now I have A squared plus H squared is equal to 4A squared. And I'm going to subtract A squared from both sides. So I have H squared is equal to 3A squared. And now I'm going to take the square root of both sides, and I get H is equal to the square root of 3A squared, which we could write as H is equal to A times the square root of 3. And now it wants us to find the length of the sides if the hypotenuse has a length of 1 unit. And if they want the hypotenuse to equal 1, that means that 2a is equal to 1. And we could say that a is equal to 1/2. If a was equal to 1/2, we would have 1 squared for the hypotenuse is equal to 1/2 squared plus h squared. And then we would have 1 is equal to 1/4 plus h squared. And then we would subtract 1/4, so we would have h squared is equal to 3/4. And then we take the square root and we get h is equal to the square root of 3 over 4, which could also be written as the square root of 3 over 2. And in problems 1 and 2, to solve B, we could have used what we found in A for both problems. And in 3, we want to find the length of the rectangle given below. And here we're going to say that length is equal to L. That's what we're trying to solve for. And then we're going to state this as L squared plus 3 squared is equal to the square root of 73 squared. And now we have L squared plus 9 is equal to 73. And then we're going to subtract 9 from both sides, so we get L squared is equal to 64. And when we take the square root of both sides, we get L is equal to 8. And then we were in inches, so 8 inches. And here, they didn't give us any units, but we probably should have put units here. And A is equal to 1/2 units. And also here for this problem as well, units. If they don't give you any specific units in a problem like this and something is in lengths, we would just call it units. And that's our video on applications of the square root property.